Section 2.5, to use bearings and subtense bars to solve right triangle problems. First topic is bearings. Other applications of right triangles involve bearings. It's an important idea in navigation. It will give us a direction and also a distance. When we deal with bearings, there are two methods for expressing them. When a single angle is given, such as 164 degrees, it is understood that the bearing is measured in a clockwise direction from due north. Let's look at another example. A car travels for 2.5 hours at the rate of 50 miles per hour at a bearing of 35 degrees. How far is the car from the starting point? So notice the only information given to us here is 164 degrees. But method one tells us that we always have to initiate a northbound direction. And from there, we go 164 degrees clockwise. And our solution would be the end point of that value or somewhere on that last ray that would give us 164 degrees. So this is how you draw a 164 degree bearing. The first thing we do is we always need to draw the diagram. We're given 35 degrees. From the previous example, we know we have to have an initial starting point of a northbound direction. Then, since it's a single degree, we're going to go clockwise 35 degrees. Now we use the other information in the problem that is given to us is 50 miles per hour at 2.5 hours. We know that distance equals rate times time. Therefore, my distance is equal to 50 miles per hour times the time, which is 2.5 hours. Therefore, my solution for distance is 125 miles. Remember always to label the problem. Let's take a look at another example. A car travels at a rate of 45 miles per hour for 1.5 hours on a heading of 50 degrees. The car turns right at a heading of 140 degrees for another hour at the rate of 60 miles per hour. How far is the car from the starting point? A lot of information is given to us, but let's start out with the initial bearing. Our initial bearing is at 50 degrees. So remember, if a single angle is given in this situation, 50 degrees, we'll deal with the other bearing later. We have a north directional to initiate the problem. We then know that we're going to go clockwise 50 degrees. That's our 50-degree bearing. Here, we can find the length or distance that the car has traveled from the original starting point by knowing the two given information about the 1.5 hours and 45 miles per hour. So we know here distance equals rate times time. We know that my rate is 45 miles per hour times my time, which is 1.5 hours. Therefore, my solution is 67.5 miles. The second part of the problem tells me another bearing of 140 degrees. This 140 degrees has to be at the end of my last bearing. So if I draw my north starting point to represent that bearing, I initiate 140 degrees clockwise and then draw the terminal side. So here's my 140 degrees. Now I can find the distance from the ending point to this ending point by knowing the other given information in the problem, which is 1 hour at 60 miles per hour. So distance equals rate times time. My rate is 60 miles per hour for 1 hour, which gives me 60 miles. But the question of the problem is, how far is this car from my initial starting point? So I can draw a line to connect those 2 points. Then I need to determine the length of that green line to find the solution to the problem. Let's consider this. The blue northbound direction and the red northbound directions represent north. Therefore, these 2 lines are parallel. If that occurs from previous sections, I know that I have 2 angles generated. These 2 angles are called same side interiors, and I know that they are supplementary. So I know that this has to be 130 degrees because these 2 angles have to add up to 180. Now, if I take a look at just this situation here, that would give me one complete revolution, which would be 360 degrees, so I can determine the measure of this angle. 130 plus 140 is going to give me 270, which tells me the measure of this angle is 90 degrees. Now I have a right triangle, and I can use the Pythagorean theorem to solve for the distance from the original starting point to where I finally ended up after two bearing changes. So let's use the Pythagorean theorem. Here, c squared equals a squared plus b squared. Substituting the values, c squared is equal to a, 67.5 squared, plus b, which is 60 squared. Now let's simplify both sides and take the square root, and we'll see that c is 90.3 miles. Let's take a look at method 2 for labeling bearings. This starts with a north-south line and uses an acute angle to show direction. And here's the key thing about doing this. When labeling bearings, either the north or the south, which means N or S, always comes first, followed by the acute angle, and then an east-west or EW to represent that direction. Here's a couple examples. As we first saw a couple of slides previously, we noticed that when I set up my compass, this is my north, this is my south, this is west, and this is east. So in this situation, I'm going to start with north, as in the previous slide said, start with north and south, but since this is going north, north 38 degrees, east. Same setup, north, south, west, east. Again, my initial ray is north, 68 degrees, west. We can continue. Again, I know north, south, west, east, and here it's going to be south, 37 degrees, east. And the last example, again, south, 77 degrees, west. Let's take a look at an example. An airplane leaves the airport flying at a bearing of north 32 degrees east for 200 miles and lands. How far east of its starting point is the plane? Let's start out with a sketch. Well, the bearing is given as north, so I know my initial ray is going to be north. I then know that it is 32 degrees east, so that is going to go in a clockwise direction, 32 degrees. And then the plane is going to land. We do know how far the plane went. It traveled 200 miles. But the question wants to know how far east this plane traveled, and that's the big question. Therefore, I need to form a triangle somehow. So what I would do is drop a vertical to that horizontal east line. That will create a right triangle. Now, we know that these two north lines, the green line here and this blue line, are north. Therefore, they must be parallel. From previous sections, they create special angles. So this angle and this angle here are congruent. So this is also 32 degrees. Once I know that this is a right triangle and this is 32 degrees, I can find the distance from its starting point to the number of miles east that that plane traveled. Now, all I need to do is take this angle, which is 32 degrees, and identify the parts of this right triangle based on this angle. I know that this is the opposite leg, and I know that this is the hypotenuse. So what function relates to opposite leg and a hypotenuse? In this situation, it is sine, which will be opposite leg over hypotenuse which will be opposite leg is x over the hypotenuse, which is 200. Now, I need to solve this equation for x. If I multiply both sides by 200, I get 200 sine 32 degrees. Now, I just substitute that into the calculator, and that should give me the distance that my plane traveled east. Here you can see I substituted into the calculator. I made sure that my mode is in degree, and when I plugged this in, I got 105.98, which approximates to 106 miles.